All right, IM2 classes. Today we're talking about the other types of quadrilaterals. We have trapezoids and kites. Um, so real quick, what makes a trapezoid is that they have only two parallel sides that are called the bases, right? The difference there is that parallelograms, both sets of opposite sides are parallel, but for trapezoids, it's only one set of sides that are parallel, called the bases. If those other two sides are congruent, we will call that an isosceles trapezoid. And then there's a kite. The kite has two sets of congruent sides. They are consecutive. They are not opposite from each other. So these bottom sides are congruent and the top sides are congruent. If it was like a rectangle or a parallelogram, the opposite sides would be congruent. Not the case here. Um, let's talk about properties of isosceles triangles, trapezoids. First, like I said, these are parallel. This is what this little triangle means, is that these sides are parallel. Also, since it's isosceles, these sides are congruent. So the parallel sides are called the bases, base one and base two. These sides are congruent, meaning they're the same. The base angles, both sets of base angles are congruent. So this angle down here is congruent to this angle down here. And then this angle up here is congruent to this angle up here. So similar to a parallelogram, except for they are on the same base. All right, parallelogram, opposite angles are congruent. Here, they're next to each other. And then the two base angles will be supplementary. So this angle plus this one down here will add up to 180. We can write all that down. It's in the book. So I'm just going to mark stuff here. Maybe I'll mark it off with, I'll say these have X degrees. These have Y degrees. So if you get an X plus Y, that's going to be equal to 180. And then they also have a mid segment. All right, this mid segment, which is halfway across, it's halfway across. So this top half would be equal to the bottom half. I'm not going to mark all that off, but it's directly in between. This length is the average of the two. So if I call, I'll say this is base one, and this one up here is base two. If we add those together, and divide it by two, because we're taking the average, it's the mean between the two, that's going to be equal to the mid segment. We'll call it M. I think those are the important ones. Let's move on and see. Yeah, so we have an isosceles trapezoid here. So angle A is 42 degrees. Find angle B, C, and D. So D is easy. Since A is 42 degrees, that means D is also 42 degrees. Awesome. And then we got to find B and C. So just like we said last time, the other base angles are congruent. So angle A plus measure of angle B adds up to 180. And we know angle A is 42 degrees. So to find the measure of angle B, we are just going to subtract from 180. So minus 42. So measure of angle B is going to be equal to 180 minus 42. That comes out to 138. So measure of angle B is 138. So that means C is also 138. Look at that. We found all those. Let's take a look at our next example here. In the diagram, the mid segment of the trapezoid PQS, so find MN. So again, it's the average of the two. So we got to just take the average of the 28 and 12. So 28 plus 12 divided by 2 is equal to the length from M to N. So 28 plus 12 is 40. Divided by 2 is equal to Mn. 40 divided by 2 is 20. Why? Okay. Oh, geez. There we go. 20 is equal to there. That's it. All right. Next, we need to find the other side. So we could set this up where we have, I'll do this both ways. We have time. So 11.5 plus, I don't know what that is. That's what we're trying to find. I'm going to call this X just so I don't have to write AB all over many times again. Divided by 2 is going to be equal to the mid segment 18.7. And so then it's just a matter of solving this. To solve this, real simple, just multiply, put a line of separation here. I'm going to multiply both sides by 2 first, so that this 2 will cancel out that 2 on the bottom. Take care of that right away. So I get 11.5 plus X is equal to 18.7. That's times 2. 18.7 times 2 is 37.4. Why do they got to do? Let me just double check my mental math there. Yeah, 37.4. Anyway, next step, I'm going to subtract 11.5 from both sides. And so that will cancel out. You get X is equal to, that's going to be 25.9. The other way to think about this is kind of like you can think about this intuitively. I like to write these out. So I have base 1 is 11.5. The mid segment is 18.7. And then I'm trying to find base 2. All right. And since it's the average between the two, I can, whatever I add to 11.5 to get to 18.7 would be the same I'd add to get to base 2. So 11.5 plus, that's going to be 7.2. I add 7.2. So 11.5 plus 7.2 is 18.7. If I do the same thing to 18.7, I get 25.9. So this is kind of how I do it in my head. All right. If you like the equation's super easy to set up and solve too. But you can do it in your head, kind of like that. Moving on. So we've got some textbook problems there. Next, we're going to talk about properties of kites. So for the properties of kites, we have the two sides. The top two sides are congruent. These two sides are congruent. We have the angles on the inside are congruent. So this angle is congruent to this angle. There is no specific relationship between the other two angles, just the ones that are across from each other here. And then next we do have the diagonals are a little special. So the diagonals on a kite, if you're looking at that, you can see that they are perpendicular. And that will do it for the properties of kites. You have the congruent angles, congruent sides, diagonals are perpendicular. Actually, this one is bisected. The short diagonal is bisected, but that's kind of easy to see. So this half of it is congruent to this half of it. So let's look at an example for the kite shown. Find measure of angle C. So we know that angle C and angle A are equal. So I'm going to call these X, just to keep it simple for what we're trying to solve. What we know about quadrilaterals, if you remember for quadrilateral, all the angles in a quadrilateral add up to 360. If you don't remember that one, you can always do the n minus 2 times 180 that we did a few lessons ago to find what the sum of those angles is. So n minus 2 has 4 sides times 180. 4 minus 2 is 2 times 180 is 360. So all 4-sided shapes, the angles on the inside sum up to 360, right? This one is, we use it quite a bit, so this one should be, might just want to remember that one. So if I add all these angles together, I have x plus x. So there's the 2 x's and then plus, and that's not a plus sign. Then another x makes it look like multiplication. Don't want that. X plus 80 plus 50 is equal to 360. So x plus x, that's going to be 2x. 80 plus 50 is 130, is equal to 360. Do my line of separation. Don't want to forget that. Then from here, I'm going to subtract 130 from both sides. So 130 minus 130, that cancels out. So all I have there is the 2x is equal to 360 minus 130 is 230. And then the last step is to divide both sides by 2. So the times 2 divided by 2 cancels out. And I get x is equal to 230 divided by 2 is 115. So that means angle C is 115 and angle A is also 115. Moving on. I guess that's it. Is that the end of the lesson? That is the end of the lesson. Cool. Moving on from quadrilaterals next time. I don't remember what. We'll figure it out next time.